For any triangle ABC, show that the following is true. Okay, let us begin. So here we'll break this into two parts. So we'll start from the left hand side, but first we will work with the numerator and then we're going to work with the denominator. And then the final step, we're going to divide the numerator at the denominator. Okay, let us begin. So what we'll do, we'll start by simplifying cotangent of A over 2 added to cotangent of B over 2 plus cotangent of C over 2. So these are half angle formulas. So we have a standard formula for each of cotangent of A over 2, cotangent of B over 2 and cotangent of C over 2. So here S is going to be the semi-perimeter of a triangle, which is defined by take the perimeter A plus B plus C and divide that by 2. We're going to use this as well. Now let's substitute all of these values. This is going to give us. Now what we can do, we can combine the three terms. So our common denominator is going to be the square root of S minus A times S minus B multiplied to S minus C. Fine. And in the numerator, we have square root of S multiplied to S minus A added to square root of S multiplied to S minus B added to square root of S multiplied to S minus C. Fine. Now we're going to take square root of S as the common factor in the numerator. So this gets multiplied to 3 times S. Now what we'll do, we'll take negative as the common factor. So that we have A plus B plus C. Fine. This is going to be divided by the square root of S minus A multiplied to S minus B times S minus C. Now what is A plus B plus C? Now A plus B plus C, that's going to be equals to 2S, which means that 3S minus 2S is going to give us simply S in the numerator. So now we have S times square root of S whole divided by the square root of S minus A times S minus B times S minus C. Now we will be multiplying the numerator with square root of S, and we're also going to multiply square root of S to the denominator such that we get S squared in the numerator. This is going to be divided by the square root of, we're going to combine to get S times S minus A times S minus B times S minus C. However, we know for a fact that if we have the square root of S times S minus A times S minus B times S minus C, so this is nothing but the area of the given triangle ABC. So that means we now have S squared over delta. So this is the expression for cosine cotangent of A over 2 plus cotangent of B over 2 plus cotangent of C over 2. We're going to keep this aside. Now we will be working with the denominator portion. Let's keep this aside for the time being. And we have cotangent of A plus cotangent of B plus cotangent of C. The cotangent of A can be expressed as the ratio of cosine of angle A to that of sine of angle A. Added to cotangent of B will be cosine of angle B over sine of angle B. And then cotangent of C will be cosine of angle C over sine of angle C. Now, from the law of cosines, we can express cosine of A, cosine of B, and cosine of C in terms of its sides. So cosine of A, that's given by B squared plus C squared minus A squared over BC, 2 times BC. Then we can also define cosine of angle B, which is C squared plus A squared minus B squared whole divided by 2 times CA. And then we have cosine of angle C. So cosine of angle C is defined by A squared plus B squared minus C squared whole divided by 2 times AB. Fine. And we also have the area of a triangle. The area of a triangle, it's given by, in terms of the sine, as half BC times sine of angle A. This is also equals to half AB times sine of angle C, and then we have sine half AC times sine of angle B. So this is another way of expressing the area of a triangle. So what we'll do, we'll use all of these formulas and try to rewrite each of the terms. So cosine of A, that can be expressed as b squared plus c squared minus a squared whole divided by 2 times bc. Now we need sine of angle A. So if we use this particular formula, then sine of angle A is going to be 2 times delta divided by bc, or we have bc over 2 delta. Then we need cosine of b. Cosine of b is going to be a squared plus c squared minus b squared divided by 2 times ac. That this is going to be 2 delta over, so we need sine of angle b, so that means we have ac over 2 delta. And then this is going to be added to cosine of angle c. Cosine of angle c is going to be a squared plus b squared minus c squared whole divided by 2 times ab. Now in place of sine of c, we're going to use this formula, and this is going to give us AB over 2 delta. Now let's try to simplify this. So here we can factor out BC from the numerator and the denominator. AC gets factored out and AB gets factored out. So this is going to be equals to B squared plus C squared minus A squared divided by 4 delta added to A squared plus C squared minus B squared over 4 delta added to A squared plus B squared minus C squared over 4 delta. Now if we combine them in the denominator, we're going to get 4 delta, and then in the numerator we'll get a squared plus b squared plus c squared. So this is the number 2. This is the sum of cotangent of a plus cotangent of b plus cotangent of c. Now what we'll do, we'll divide 1 with 2. So let's divide 1 with 2, and this is going to give us the left hand side. So on the left hand side, now we are going to have s squared over delta whole divided by a squared plus b squared plus c squared divided by 4 delta. That this will be equals to 4 times s squared divided by a squared plus b squared plus c squared. The numerator can be also expressed as 2 times of s whole squared divided by a squared plus b squared plus c squared, and 2s can be replaced with a plus b plus c whole squared divided by a squared plus b squared plus c squared. And this is the expression on the right hand side. So hence we have successfully verified that cotangent of a over 2 plus cotangent of b over 2 plus cotangent of c over 2 divided by cotangent of a plus cotangent of b plus cotangent of c, that's equals to a plus b plus c whole squared divided by a squared plus b squared plus c squared.